Okay, sorry, we just had to pick up on example number 3. I was just showing you that this part could be 0 right here, or this part could be 0, in which case I need to finish the 4p minus 1. So I would add 1 to both sides, and 4p equals 1, so p equals a quarter. So some of this will be familiar to you from before. So these are non-permissible values for p. There's 2 of them, 0 or a quarter. So you may recognize that in 20-2 I was telling you to divide out by the 4 and then change the sign. That would be your p. All right, so if I look at class example number 3, I'm going to put in here that I need to factor the denominator again. So difference of 2 squares, a and minus 7 and plus 7. That's in factored form. So from both of these, I have non-permissible values. A positive 7 would create the first parenthesis to be 0, and a negative 7 from the second bracket. All right, let's look at the last one. If I was going to factor the denominator, I would pull out a 2. That will leave me with x squared plus 4. So there's nothing from the front here that would give you a non-permissible value. That can never turn into a 0. It's a 2. However, what about this? Can that ever be 0? And so you could go, I don't know, let's check. X squared plus 4 equals 0. When? Okay, subtract 4. X squared equals negative 4. Uh-oh, problem. You can't take the square root of a negative 4. So in fact, if you were to think back on that, there is nothing that you could plug into x that you would square, multiply by itself, and then add to 4 that would ever create this to be a 0. So there are no I don't know how to say it, no non-permissible values. It's like 2 negatives. Or you could say everything, every value of x is allowed because it will be squared, which will make it positive, and then you will add 4 to it. No big deal. So if we are asked to state restrictions, we're going to say x cannot be negative 2 from there. We're going to say p cannot be 0 or a quarter, and a cannot be 7 or negative 7. That is how you say state restrictions, and there are no restrictions here. Okay. Now, in this case, it says write a rational expression with the given variable and the non-permissible value. The variable is x. The non-permissible value is 3. So we would have to think of what would our expression look like if we were using an x and you weren't allowed to have a 3. How about x minus 3? Wouldn't it be true then that x could not be a positive 3? Because it would turn into a 0 on the bottom? I'm going, yeah, true. What about if the variable was an a? We're going to use an a. We're just going to put 1 on the top. You couldn't have a 0 or a 4. Probably put an a in the front to show that could not be 0, and then a minus 4. That would give you the non-permissible values or the restrictions. A would not be able to be 0 or 4. And last but not least, what if the variable was a p and the non-permissible value was 1/3? Well, let's just put negative 1/3 like this, but we know how to write that differently. We can say, we can kick this 3 up to here and make it 3p minus 1. That is a rational expression in which the non-permissible value is 1/3. All right. Hopefully that made a little bit of sense. Away you go. Don't forget you're going to have to factor.